Hello friends, myself Pundalik Patil, Professor Pundalik Patil from SND College of Engineering, Yeola, from Mechanical Engineering Department. In our lecture series, Tribology lecture series, we have to see today's lecture on frictions. Previous lecture we have seen introduction of these frictions. In this lecture, we have to see various types of frictions with their examples and how the load, normal forces and frictional forces are act on the contacting surfaces. Okay, so first of all, how to classify or how to categorize these frictions? Okay, so first of all, the major classifications of these frictions are always static friction and kinetic frictions. Okay, so the major on static and kinetic frictions. So under the static frictions, the friction between the contacting surfaces at the start of the relative motion is known as static frictions. Okay, and the kinetic friction we can define the friction between the contacting surfaces during the relative motions is known as kinetic frictions. Again, on the basis of type of relative motions, we can classify it as a sliding friction and rolling frictions. Okay. So, in sliding friction, it is the friction between the contacting surfaces having relative sliding motion is known as sliding friction. So, the example is friction in journal bearings. Then another type is rolling frictions, the friction between the contacting surfaces having relative motion is known as rolling friction, and the example is fan bearings or friction between automobile tires and road or locomotive wheel and rail. And third category is based on lubrication between these contacting surfaces: dry, boundary, fluid and mixed. We are always seen in previous lecture. So sliding fluid is viscous friction. Rolling friction in which there is relative motion between the two contacting surfaces, and static under rest conditions. Okay. So first of all, see static frictions. Okay. So in these static frictions, friction that occurs when the surfaces are in contact are at rest. So these two bodies are not in motions. And for the example, a book resting on a desk or a plant potted or sitting on the sidewalk. Okay. So these are some examples of the static frictions. Then we are having this rolling frictions. So rolling friction is a friction that occurs between surfaces in motions. Okay. So, and under this, the relative motion is rolling, in which one of the surfaces is a wheel, roller, or ball. For example, riding a bike, tire and ground, ball and lane in ballings, or fan bearings, ball and cages, race cages. Okay. So you see some example of this rolling friction. Under this ball bearing, various ball bearings or rail wheels or gear transmissions, in which rolling action takes place and the rolling friction is observed. Then we are having fluid friction or viscous frictions, the forces that tries to slow object down when they are moved through a liquid or gaseous substance phases, and it is also known as drag or air resistance. And all these gaseous or liquid or fluids, and this fluid friction increases as the speed of the object increases. So for example, an airplane or a swimmer in a sea, both experience fluid frictions. Then we are coming to this sliding frictions. Sliding friction is a frictional force that opposes the direction of motion of an object that occurs. And when solid surfaces are slide over one another. And for example, writing pencil point and paper, or combining your surface of palm and hands. So here we are seeing the inclined plane rig on which we have to determine the frictions. So a specimen is placed on a flat plane whose inclination with the horizontal is gradually increased until the specimen on it start to sliding. Okay, and the angle of inclination theta at the moment is measured. Okay, so here this is the inclined plane, this is the object, and we have to put this inclination angle so that the body may slide, and under it the normal loads and tangential forces are applied, and force frictional force is equal to this mu into F. So where mu is the coefficient of frictions, F is the normal load, and F frictional force. And from it we can find as frictional forces. So how the friction takes place in our applications, what are their causes, how to minimize these frictions so that the energy will be saved. So in today's lecture, we are seeing the various classification of these frictions and how the normal loads are act on the surfaces and get the friction. So today we will stop here. We are seeing in next lecture as a law of frictions. Okay, thank you.